Welcome to i9 Global. Join us as we delve into the basic foundations of artificial intelligence. Today, we're going to explore the topic, AI model. An AI model is a computer program trained on data to recognize patterns or make decisions without constant human input. These models use algorithms to process data and produce results based on what they've learned. In simple terms, an AI model is defined by its ability to make predictions, decisions, or generate outputs independently. One of the earliest examples dates back to the 1950s, when models were used in checkers and chess programs that could respond to human moves rather than follow fixed instructions. You can also think of an AI model as a computer system trained on a specific dataset to learn patterns, relationships, and characteristics. Once trained, it can apply this knowledge to new, unseen data without needing further human guidance for each case. Think of it like teaching a child a skill. Training. You show the child many examples, the dataset, of how cats and dogs and tell them, this is a cat, or this is a dog. To do something, like recognizing different animals, you might show them pictures of learning. The child starts to pick up on the features that differentiate cats from dogs. For example, shape of ears, sound they make. This is analogous to the AI model adjusting its internal parameters based on the data. Application. Inference. Once the child has learned, you can show them a new picture of an animal they haven't seen before, and they can tell you if it's a cat or a dog. The AI model does the same, applying its learned knowledge to new inputs. AI models vary in effectiveness depending on the task. Some complex systems use multiple models combined via techniques like bagging, boosting, or stacking to improve performance. Key characteristics of AI models. Learns from data. Unlike traditional software that follows explicit, hard-coded rules, AI models learn by analyzing large quantities of data. Pattern recognition. They excel at identifying complex patterns and correlations within data that might be imperceptible to humans. Autonomy. After training, they can operate independently to perform tasks or make decisions. Adaptability. Many AI models can continue to learn and improve their performance over time as they are exposed to new data. How AI models work. 1. Data preparation. Relevant data is collected, cleaned, and transformed into a format the model can understand. For example, images converted to pixel arrays, text to numerical representations. 2. Model selection. An appropriate AI algorithm. For example, a specific type of neural network, decision tree, or regression model is chosen based on the problem to be solved. 3. Training. The prepared data is fed to the chosen algorithm. During this phase, the model iteratively adjusts its internal weights and biases to minimize the difference between its predictions and the actual outcomes in the training data. 4. Evaluation. The trained model is tested on a separate, unseen dataset to assess its performance, accuracy, and ability to generalize to new situations. 5. Deployment. If the model performs satisfactorily, it is integrated into real-world applications or systems. 6. Monitoring and refinement. Even after deployment, models are often monitored for performance degradation. For example, model drift, and can be retrained with new data to maintain or improve accuracy. Types of AI models. AI models can be classified based on their learning method. For example, supervised, unsupervised, reinforcement. Their intended function, for example, classification, regression, or their underlying structure, for example, decision trees, neural networks, transformers. Classification of AI models based on their learning approach. Supervised learning models. Trained on labeled data, input-output pairs. Examples include models for image classification, identifying objects in pictures, or spam detection. Unsupervised learning models work with unlabeled data to find hidden structures or patterns. Examples include models for customer segmentation or anomaly detection. Reinforcement learning models learn by interacting with an environment, receiving rewards for desired actions and penalties for undesired ones. Examples include AI for playing games or controlling robots. Deep learning models, a subset of machine learning that uses multi-layered artificial neural networks. They are highly effective for complex tasks like natural language processing, understanding human language, and advanced computer vision. Generative AI models, a newer type of model, often deep learning, capable of creating new content like text, images, or audio that is similar to the data they were trained on. Classification of AI models based on their intended function. Classification models. These models assign input data to predefined categories, producing discrete labels. For example, spam or not spam. Examples include logistic regression, decision, regression models, designed to predict continuous numeric values. These models output real numbers, for example, temperature, price. Linear regression and neural networks for regression are common examples, with applications in house price prediction and stock market forecasting. Clustering models. These models group similar data points without predefined labels, generating cluster IDs. Examples include k-means and db-scan, used in customer segmentation and market research. Anomaly detection models, focused on identifying unusual patterns. These models output binary classifications, normal, anomaly, or scores. Common examples are isolation forest and autoencoders, utilized in fraud detection and network intrusion detection. Recommendation models. These suggest relevant items to users based on behavior or preferences, producing ranked lists of items. Examples include collaborative filtering and matrix factorization, with applications in personalized content feeds and e-commerce suggestions. Classification of AI models based on architecture, model structure. Decision trees. These are simple models that split data into branches based on feature values, commonly used for classification, regression, and rule-based decision-making. Artificial neural networks, ANNs. Modeled after the human brain, ANNs consist of interconnected layers of nodes, neurons, and are primarily utilized in image recognition and speech processing. Convolutional neural networks, CNNs, specialized for grid-like data, such as images. CNNs excel in tasks like image classification, object detection, and medical imaging. Recurrent neural networks, RNNs. These networks are designed to process sequence data, making them suitable for language modeling, speech recognition, and forecasting applications. Transformers. Utilizing self-attention mechanisms, transformers manage sequences without relying on recurrence, and are widely used in machine translation, chatbots, and code generation. For example, GPT, BERT. Major models in artificial intelligence. Foundation model. A foundation model is a large-scale, pre-trained AI model that is trained on a massive amount of diverse data and serves as a base for building many different AI applications. These models are called foundation because they provide a general-purpose starting point that can be fine-tuned for specific tasks like text generation, translation, image recognition, coding, and more. Imagine a super smart student who has studied everything. They've read countless books, articles, listened to endless conversations, and seen millions of images. Because they have such a vast and broad understanding of the world, they can then be easily taught to do many different new things without starting from scratch. A foundation model is like this super smart student. It's an AI model that has been trained on a huge amount of very diverse data, text, images, code, etc. This massive training gives it a broad, general understanding of patterns, relationships, and knowledge across many different areas. Because of this strong foundation, it can then be easily adapted or fine-tuned to perform a wide variety of specific tasks. Think of a foundation model as a highly skilled generalist contractor who knows how to build the strong basic structure of any building, house, office, school. Once that strong foundation is laid, it's relatively easy to customize it into a specific house, office, or school by adding the finishing touches. Examples: GPT-4 from OpenAI. This model has been trained on a massive chunk of the internet's text and code. Google's Gemini. Similar to GPT, Gemini is a foundation model that can understand and generate text, images, and even code, making it versatile for many tasks. Generative model. This is a type of machine learning model designed to create new data that is similar to the data it was trained on. Unlike traditional AI models that primarily analyze or classify existing data, for example, telling you if an image is a cat or a dog, generative models focus on understanding the underlying patterns and distributions of data so deeply that they can generate novel content. It is an AI model that's good at creating brand new things that look or sound like the data it was trained on. Instead of just understanding or classifying existing data, it can generate novel content. It learns the underlying patterns and styles of the data it saw, and then uses that knowledge to produce something original. Think of it this way. Discriminative model. If you give it a picture of a cat and a dog, it tells you which one it is. It discriminates between different categories. Generative model. If you ask it for a picture of a cat, it creates a new, never-before-seen picture of a cat. It generates the data itself. A generative model is like a creative artist. If you show an artist many pictures of cats, they can then draw you a new cat that's never existed before, but still looks like a cat. They've learned the essence of a cat. Examples: DALL-E or Midjourney. Deep fake technology. Large language model. LLM. Large language model is an advanced type of artificial intelligence model that is trained on massive amounts of text data to understand, generate, and manipulate human language. LLMs are built using deep learning techniques, particularly the transformer architecture, and are capable of performing a wide range of natural language processing tasks such as writing, translation, summarization, question answering, and more. Large language model is a specific type of foundation model that specializes in understanding and generating human language. The large part means it has been trained on an absolutely enormous amount of text data. Think trillions of words from books, articles, websites, and conversations. Because of this vast training, LLMs become incredibly good at predicting the next word in a sentence, understanding the meaning and context of text, generating coherent and human-like paragraphs, essays, and conversations. An LLM is like a librarian who has read every book in the world plus every conversation on the internet. They don't necessarily understand in a human sense, but they know exactly how words and ideas connect, what sounds natural, and how to answer almost any question or write about any topic. Examples of large language model: ChatGPT, and the models behind it like GPT 3.5, GPT-4. Google's Bard, Gemini, text-based capabilities. Natural language processing, NLP models. Natural language processing models have become indispensable tools in the realm of artificial intelligence, designed with the primary purpose of understanding, interpreting, and generating human language. These sophisticated algorithms leverage vast datasets and advanced machine learning techniques to bridge the gap between human communication and machine comprehension. By analyzing linguistic patterns, context, and semantics, NLP models can decode the nuances of language, enabling them to respond intelligently to user queries, summarize lengthy texts, and even translate languages in real time. The evolution of NLP has been marked by significant milestones, from rule-based systems to the advent of deep learning approaches. Early models relied heavily on predefined rules and lexicons, limiting their adaptability and understanding of context. However, the introduction of neural networks and transformer architectures has revolutionized the field, allowing models to learn from vast corpuses of text. This shift has enhanced their ability to grasp idiomatic expressions, cultural references, and emotional undertones, ultimately leading to more human-like interactions. One of the most notable applications of NLP models is in customer service automation. Chatbots and virtual assistants powered by NLP can handle a multitude of inquiries, providing timely responses while reducing the burden on human agents. This not only improves operational efficiency, but also enhances customer satisfaction by delivering personalized experiences. Furthermore, businesses can analyze customer feedback and sentiment through NLP-driven analytics, gaining valuable insights that inform product development and marketing strategies. That brings us to the end of this video. In our next video, we will dive into AI algorithms. Don't forget to follow, like, and share. If you have any questions or suggestions, feel free to drop them in the comments section. Thank you for watching.